One of the habits that sometimes comes over from the world of spreadsheets is the tendency to try and store multiple pieces of information of the same type in a single field. This typically shows up as a comma-separated list of values, where one record has several corresponding data items. Here's an example of what this might look like. Let's suppose that we wanted to keep track of the names of our employees' children as part of the health benefits that we provide. An initial thought would be to simply create a new column in our employees table and place the names there. When we do that, however, you can quickly see what happens. Any employees that have more than one child have that information stored as a list of multiple names. Once again, we have a structure that will work well for us personally, but doesn't help the database organize your information in the most efficient manner. This is what's called a multi-valued field, and it's inherently difficult to search through. If we were to ask the database for the employee with the child named Jeffrey, then the database management system would need to parse out the text, looking for commas, to determine the individual names. This structure only solves the immediate problem of having a place to store data. While this might work in a loose understanding of a table, we can already see that this doesn't meet the stricter requirements of a relation in that we have multiple elements in a single field. A second attempt at trying to store this information might look something like this. Here I've broken the multi-valued field into columns for each child. This is slightly better in that the database will no longer need to parse text strings in order to get to the individual values. But we need to instruct the database to look in either the child 1 column or the child 2 column, as we wouldn't be sure in which one Jeffrey was stored. Further, what happens when we have an employee that has 3 children, or 5? Surely 10 would be enough, right? Unfortunately, we just can't keep adding additional columns in an effort to stay ahead of the worst-case scenario. Believe me, that is going to be a losing strategy. The solution to this problem in the world of a relational database is the same as we've done several times already. Break out the problematic elements into their own tables and link them back together with some sort of reference fields. For our child tracking needs, it'll look something like this, where each child gets his or her own record, and the related parent information provides a way to link it back to the original employees table. The advantages of this are many. First and foremost is the fact that we now have a single location to look up information about our employees' children, and we don't need to parse text in order to get to the individual names. The second is that we don't get in the habit of creating tables that need to change in order to accommodate new records with different parameters, such as adding a child 3 or a child 4 column. One of the best rules of a good database design that I've heard is something called the open-closed principle. It states that tables should be open for extension and closed for modification. This means that everyday data entry tasks will continue to add new records to the database's tables without a need to alter the structure. In other words, end users will grow the database vertically, while a developer is required to grow the tables horizontally. Now there's one more example that I want to resolve before moving on. We've taken several looks at our invoices table, and there's been a major problem hiding there all along. So far, our invoices table has only allowed a single entry field for the products ordered, but obviously, we'll want to allow our customers to be able to purchase several items at once. This is actually another instance of a potential multi-valued field in hiding. Luckily, the solution is exactly the same. We'll pull out the product being ordered and the quantity, and use them to create a new line items table that refers back to the original invoice. Now the invoice table will only store information about the overall transaction, including the date, the customer, the shipping address, and so on. Then, to find out what was actually ordered, we'll take the invoice number and look up the individual line items in the new table. This will give us each product, regardless of how many products appeared on the invoice, and the quantity of each product ordered. Now our database correctly captures the full order fulfillment process. So the problem of a multi-valued field takes on 2 forms. First, we'll look for any comma-separated list in a single column of values. This is a key indicator that you've got a multi-valued field that needs to be resolved. The other format that we'll recognize is having columns named the same, but numbered 1, 2, 3, and so on. This is really an indicator of a multi-valued column in disguise. It also needs to get resolved. Making additional data tables to house the multiple values takes care of the problem easily once you've identified the issue. So I hope these examples have been helpful in understanding the benefits that a relational database brings to the organization of your information. If you're moving from the world of Excel spreadsheets, then you will appreciate the level of control, consistency, and accuracy that you'll gain. The next step is to start digging into our own data requirements and developing a model that captures our business needs. We'll start doing that in the next chapter.